G'day and welcome back. Here we have our standard Slayer exciter circuit, and we're just running everything in standard mode. As you can see, it's running pretty efficiently, and we also have it running in standard mode where we take the base and feed it back as per to the base of the transistor, but with one minor difference that you might have noticed. We're using resonant coils. There we go. So to prove this, what I'll do is, we can see our little lights on there. What I'm going to do is I'm going to move that out of the way and you'll see the light go dim. There we go. And so it's gone out of resonance. Now they appear to be quite some distance apart, and our light's out. And we're not drawing very much current at all, or voltage actually. But let's see if we are doing anything out of the unusual. Let's grab that one. Oh, look at that. That's on. So it's still working as it should. So what's actually happening is the super high voltage is coming back through this coil, which is exactly the same as this coil, came out of an old drill, and then it's making its way back to the base of the transistor. The other way I'm going to show this is I'm going to put that nice and close so it's on, and I'll just take off this one and you'll see the light go out. And the light's gone out. So that proves that it's working the system via induction. And if the further we move the coils apart, the less induction we got, the less stress there is on the system. As you can see, it's using 4 milliamps. And we're going to have, look at that. As you can see, the voltage has gone down, but the current hasn't changed. Now, what I will do is I'll introduce an earth to this one. And now we can see that the induction is still there. The question is, how far apart can we put them before we lose induction? And as you can see, with my help, it's staying on, off, on, off. So it's not that far, it's about 6 inches, I'm guessing. Isn't that interesting? So the question is then, what I'm going to introduce now is, oh, by the way, let's have a look at the voltage on here. If I move it away, the voltage drops, light goes out, a bit closer. That's interesting, isn't it? But now what I'm going to do is I'm just going to demonstrate this, which is I found very interesting. As you can see, they're nice and close. Everything's on. That's quite efficient. Our light's on, in fact. But watch what happens when I put the light over to this one. Zippo, nothing. Absolutely no induction. And that's because this one's got a physical, I guess, high voltage, super high voltage going through it from the coil there. So that was the first thing I found interesting. The fact that, okay, it's creating a circuit, but I can't get any power from this one, which is pretty interesting. I don't know why that is. Maybe you can tell me. Now the next thing I'm going to do is quite interesting. I don't know why this helps, but it does. Maybe it's got something to do with the demonstration of the last video. But let's take the top of the Tesla coil, and all I'm going to do is attach it to here, not actually touching the wire, but encompassing the coil. And what I've found is this actually makes a very efficient system, and also means that our light or our induction goes over a much larger area. I'll try and demonstrate. So as you can see, the distance is quite some ways that it's crossing and inducing. And to prove that it's inducing it, I can disconnect this one again. As you can see, it's using a little bit more because it's under a bit of pressure, but if I take that off, it goes off. So that means it is going over that distance, which is interesting. And now it's back on. And so I could still go probably, that's probably half a metre, could still probably go another couple of 100 mils, but I thought that was an interesting demonstration. Finally, they're side by side, and once again, full induction there, absolutely nothing there, right beside it, unless it touches the actual physical wire, which is coming from the top, remember. Isn't that interesting? So whilst it is inducing the other coil, it's actually something's going on that I don't really understand. The thing is, when it's inducing like this, one coil inducing the other one to make the circuit, you can see the lights on now, side by side. This one will go, this one won't, that one won't. But what is interesting is, when I join these two coils together, alright, obviously that's a lot brighter, if it would focus. There we go, it's using a lot more. But guess what? Neither of them are going. And the line is now dead to the high voltage, which I found very interesting, probably because it's going back to that base. So I thought you'd find that interesting. Let's just go to there. That one should work because it's coming off the top. Yes, it does. So there you go. A very interesting experiment. Thanks for watching. Catch you later. So now, just to confuse everyone and everything, I'm going to put the induction between the two coils into super duper mode. Super duper mode. All right, so what we're going to do is take the top of our coil that we had on there, as you can see. It tends to work quite well. And now I'm going to short circuit the system basically, and it comes on again. But what actually happens is I'm able to separate these a long way, and I'll just try and be careful because it's got some glitches in the system. But anyway, such a long way away, and it's still perfect brightness, still that's going. Of course, it's got a bit of a drain going. I'll try and move it even further away as possible, and it's still going. So that's as far as I can go. So that's quite a lot of resonance. I encourage you to have a bit of a crack at that one and see what you think. So I don't know why it's working, and just to show you that it's not, the system's not losing any resonance. Let's go with this here. There we go, still going. And in fact, from on here, and even on this one, not so good, see, but there is a little bit. That's interesting. But yeah, I thought you'd find that very interesting. Yeah. So I wonder how much further we could push it. Anyway, thanks for watching. Yeah, tell me what you think about that.